Hey everyone, Professor Adjovan here with episode 16 in the linear series where we're going to talk about parallel and perpendicular lines. As normal, we're going to do three examples in this video. The examples are on your screen now, so if the types of problems that you're working on currently look like these problems, then this is the correct video for you. So let's go ahead and jump into it. So before we do the problems, let's talk about what parallel and perpendicular lines are and some notation for the two of them. Okay, so parallel lines are going to be two lines that never intersect. All right, they never intersect. So if we think about these as equations in the form of y equals mx plus b, if they're never intersecting, then they must have the same rise and run. All right, they need to be going up the same amount as they're going over the same amount to keep them from intersecting. So the slope are the same. That's the key, that the slopes for parallel lines are the same. Now there is a symbol for parallel lines, and it looks like two parallel lines. So if you ever see this symbol, sometimes it's written vertically. Either of those symbols where it looks like two parallel lines, that means it's asking you to find two parallel lines. All right, perpendicular has a symbol like this. Perpendicular means that there is a line and there is another line that intersects it at a 90-degree angle, which is really interesting. If we have an equation of one of the lines in y equals mx plus b, the other equation that makes the 90-degree angle, a lot of people will think it's just negative mx plus b, right, to give you that negative slope, but that's not exactly correct. We need not only the negative for the slope, we need the negative reciprocal, which just means that we're going to take m, whatever our slope is, and we're going to put it in the bottom of a fraction where the numerator is 1. So parallel is pretty straightforward. The slopes of the two lines are the same, but perpendicular, the slopes of the two lines are opposite reciprocals. All right, and this will be easier to understand once we start looking at a few examples. All right, so let's start with a parallel example. So we're given a point and we're given an equation. So I want to find the equation of another line that is parallel to the one that I'm given and is going to go through this point. Okay, so we know that parallel lines have the same slope. So if I take the equation that I'm given, I can take this slope 1/5 and let that be the slope of the line that is going to be parallel to this given line. So I know my slope, I know m, and I'm also given a point. Well, we know how to find the equation of a line with a slope and a point. We can do it a number of ways. We can use slope-intercept form, or we can use point-slope form. So if we use slope-intercept form, because I feel like that's always a student favorite, we would take y equals mx plus b, plug in the -4 from the point that we have for y, plug in the 1/5 for m, plug in the 5 for x that we're given, plus b, and now we're just solving for b. Right, so 5 times 1/5 is going to be 1. So subtracting 1 from both sides, we're going to get b is equal to -5. So our equation of a line that's going to be parallel to this and passing through this point is going to be y equals the same slope, 1/5, x minus 5. All right, so this is for parallel, where we are given a point in a line. What if we're given a point in a line and we want something that is perpendicular? All right, so we have the point -6, -3, and I want the equation of a line that's going to go through this point and be perpendicular to the equation y equals -2/3 x plus 4. So we know that the equation of a perpendicular line needs to have that opposite reciprocal. So whatever the sign is of the slope, I'm going to change it. So the slope of my equation that's going to be perpendicular, instead of being negative, it's going to be positive. And instead of being 2 over 3, we're going to do the reciprocal, which just means that we flip the fraction. So I want positive 3 halves. As soon as I identify what the slope is, we have the slope and we have the point. So again, we can use y equals mx plus b, plugging in the y of negative 3, the 3 halves of x, or of m, and negative 6 for x, and we can solve for b. Right, so negative 3 times 3 halves is going to give us negative 9. And if we add negative 9 to both sides, we'll get 6 is equal to b. Alright, so we have our b, we have our m. We can write this perpendicular equation in slope-intercept form with y equals 3 halves x plus 6. Alright, so we looked at two different examples where we're finding the equation of a perpendicular line, where we are finding the equation of a parallel line. But what if we're given two equations? And we want to determine, are these parallel, are they perpendicular, or are they neither? So what I recommend is to write them in the same form. For example, we could write them in slope-intercept form, y equals mx plus b. So this first one is already written in y equals mx plus b. I can do the same thing with the second one. I can rewrite this so that it's y equals. So let's do that. Right, I can subtract negative 2x. So we have negative y is equal to negative 2x plus 3. And I can divide both sides by negative 1. Doing this will give us y equals negative 2x divided by negative 1 becomes positive 2x. Positive 3 divided by negative 1 becomes negative 3. So this is our second equation, and we'll rewrite the first one so that they're right next to each other. And what do we notice about the slopes? That's what we're trying to identify. The slopes are the same. The same slopes tell us that these are parallel lines. If the slopes were opposite reciprocals, then they would be perpendicular lines. If they were neither the same nor opposite reciprocals, then they would be neither parallel nor perpendicular. Alright, that's it for this video on parallel and perpendicular lines. I hope you found it useful. If it was useful, consider giving this video a like and consider subscribing to the channel for more math content. Thanks for watching, good luck, and we'll see you in the next one.